Let's look at exponents that contain zeros. So if we were given 7 squared over 7 squared, we can expand. So this would look like 7 times 7, and we can multiply and see that we are given an answer of 1. 49 divided by 49 is equivalent to 1. Let's look at another example. Let's change this up. So let's go with 9 cubed, 9 cubed, and we're going to divide that by 9 cubed. And you're going to see this, 9 times 9 times 9, and that's going to be over 9 by 9 by 9. And when we expand, we end up with 729 over 729. Simplify, you end up with 1. Okay, let's move on to one that looks like this. Let's go 2 to the 4th power divided by 2 to the 4th power. Okay, so I'm just going to show this like this, and then we're going to expand and simplify. Okay, we end up with 16 over 16, and of course that is equal to 1. Now, let's look at each of these examples just in a little different light. So we're going to try to solve these a different way. Try to go back to that same color, purplish blue that I had there. I don't know if it's going to be the same, but it should be close. So we can also, using our rules, I'm just going to draw a little line here. Using our rules for exponents, you know that when the bases are the same, you're going to subtract your exponents. So this example here, okay, we'll say this is example 1, and we're going to say this can be example 2, solving the same operation. So let's look at this. 7 squared divided by 7 squared. We know that when the bases are the same, you can subtract your exponents. 2 subtract 2, that's going to give you 7 to the exponent 0. Okay, now we're just going to hang on to that idea, that answer, and we're going to come down and we're going to look at the third. We'll call this example 3. Put a little line here, and we're going to use the same scenario as example 4. And again, like bases, you're going to see 3 subtract 3. We're just solving it a different way, right? These are all patterns, and you end up with 9 to the 0 power. Now let's go back to this particular example, okay, and we'll call this one our 5th example. And you see how we solved that and what we ended up with. But we're going to do the same, we're going to follow the same pattern, we're going to do the same thing that we did in the previous examples, and we're going to have 2 to the 4th divided by 2 to the 4th with like bases. It's going to look like this, which gives us 2 to the 0 power. Now we can make a conclusion based on this. We can keep going with these, but we're going to have the same answer and the same pattern. You're going to find the same pattern, and what you're seeing is in these examples, any number expressed to the exponent 0 is equal to 1, and you see it here. And as I said, we can keep on going with a bunch of different examples, but it's not going to change. It's not going to, oops, excuse me, it's not going to change what we're doing here in terms of patterns and in terms of our answers. So we can show this. So anything to the power 0 is equal to 1. Okay, so you could have something, you could have something like this, 12 to the power 0 is equal to 1. 55 to the exponent 0 is equal to 1. Any number expressed to the exponent 0 is going to be equal or equivalent to 1. So we can show this like so. A to the 0 power is equal to 1, and A cannot equal 0.